more than 60 people who registered for this pilot. And it's a nice combination of people who haven't been to Classes Without Quizzes for a while, some who are regulars and have been here within the last 5 years, and some folks who are joining us for the first time. So thank you all for being a part of this pilot program. And I think that most everyone is in Minnesota, so we were just talking about the rain that we got last night. Hopefully that was good for your gardens and your fields. And I know we do have someone from California, so hope you're doing well and not too hot out there near Sacramento. Thanks for joining us today. And we also have a few of our high school ag instructors who are checking this program out. As you can imagine, it's been an interesting time for all teachers, whether you're faculty on campus or teachers in high school or in elementary school, switching to remote instruction. So hopefully this will be a great resource for some of you high school teachers to share about some of the research that is happening here on the St. Paul campus. So it's just about noon. We'll start in about a minute or two here, give everyone a chance to log in. Welcome to everyone who's just joining us. We're scheduled to start at noon, but we'll just give everyone an extra minute to get logged in. Hopefully that went smoothly for everyone. All right. Good afternoon and welcome everyone to our very first virtual edition of Classes Without Quizzes. My name is Mary Bichetti and I'm the Director of Alumni and Constituent Relations in CFANS. Since our first program in 2002, which featured U of M climatologist Mark Seeley, Classes Without Quizzes has been a flagship program for the CFANS Alumni Society. We took a break in 2019 and with vision, commitment, and leadership from the Alumni Society Board of Directors and expertise from our new CFANS event manager, we are excited to pilot this virtual edition of the program. I'd like to welcome our host for the session and the chair of Classes Without Quizzes, CFANS alumna, Annie Makepeace.
Thanks, Mary, and welcome everybody to Classes Without Quizzes, the virtual edition. I am a 2015 CFANS grad with a master's in applied plant science. I currently work as a technical marketing manager for Winfield United under the Land O'Lakes umbrella, and in addition to serving as the committee chair for Classes Without Quizzes, I also served as the president of the CFANS Alumni Society Board for this previous term, and I'm entering my 6th year serving on the board. I'm really excited about transitioning this event to a digital platform. We've been exploring how to evolve Classes Without Quizzes for a couple of years now. And just with everything going on in the world and our committee's desire to reach a broader audience with this content, this just seems like the perfect time to debut this new platform. So we really appreciate your input on this pilot event as we look to the future. We're exploring both virtual and in-person options for the future and considering what the content might look like for future programs. Classes Without Quizzes truly brings to life our board mission, which is to foster relationships that benefit our college, alumni, students, and friends by sharing this fascinating and important research that's going on at CFANS with all of you. So thank you for joining us, and we hope you enjoy the program. But before we begin, I'd just like to take a quick moment to thank our 2020 Alumni Society sponsors, including the Diamond level sponsor, COMPEER Financial, Platinum level sponsor, Agribank, and supporting sponsors, Grain Millers, CoBank, Midwest Dairy Association, BMO Harris Bank, Christensen Farm, and Minnesota Farm Bureau. It's their generous contributions that make our programs, student scholarships, and events like this one possible. So thank you to those joining today who are employees of these organizations. And if you know representatives of these sponsors, please share our gratitude for their support. And now, to kick us off today, it's my pleasure to introduce Dean Brian Bohr. Dr. Bohr came to the University of Minnesota in 1992 as a faculty member in the Department of Applied Economics, where he shared his expertise in commodity marketing and livestock markets, among many other things. He was appointed as head of the Applied Economics Department in 2008, and in 2014 became the dean of our college. Please join me in welcoming Dean Brian Bohr.
Thank you, Annie, for that introduction. And I'm going to tell people to stop using the 1992 pretty soon here, because that seems like an awfully long time ago. But I do want to thank the Alumni Society Board, and I want to thank everyone who's participated in helping to bring this together for our first virtual class out quizzes. Of course, I think I was at the first one in 2002 and used to speak at these quite a bit. It was a great opportunity always to bring together people and have a highlight about what the research is going on across CFANS, the breadth of work that we do. Unfortunately, we hope everyone is doing well and healthy, that we couldn't get together here, but as Annie was saying, exploring this new platform is a way perhaps to engage much more readily and easily and reduce some of the, I know for people it's always tough to take time in a day away from busy lives and families. Here's an opportunity to bring that in a more seamless way into your lunch hour, I guess, today a little bit. So we're delighted to host this again. We're grateful for everyone who's contributing to this today. Certainly I want to thank Carmen Fernholz for agreeing to spend some time here. Jake Jungers, a faculty member in Agronomy, for taking time to participate as well and do this. And today they're going to talk about, in fact, just this morning, I spent a good hour and a half on a call regarding Forever Green, and really its potential to both improve our economics of agriculture systems for farmers, but also how do we develop crops that can impact and improve the environmental and ecosystem services on the landscape, improve soil health. So really has been a growing project. Started, a lot of people look at research and they think, well, that was easy. When you start to get to the point where it's having impact, has been going on for 20 years. It really illustrates, I think, the value of the long-term investment in research that's required to move agriculture and food systems forward. And so it's just a great enterprise that's really has some engagement with industry, with farmers, with retailers, with environmental impacts. So it's really exciting to see this presented today. So with that, thank you all for joining us, and I'll turn it over. So thank you all for coming.
Now on to our featured speakers. We're excited to welcome two Kernza experts who will be sharing information on this exciting new sustainable high-value perennial grain crop that was developed at the Land Institute and researched by scientists and farmers within the Forever Green initiative at the U, like Brian mentioned. Dr. Jake Jungers from the Department of Agronomy and Plant Genetics at the U of M, and organic farmer Carmen Fernholz, who has worked closely with the university on several research projects. A Wisconsin native, Jake Jungers joined the faculty as an assistant professor in 2017. His research is focused on improving and developing new cropping systems that provide high-value agriculture products, mitigate environmental pollution, and reduce greenhouse gas emissions. His goal is to improve nutrient use efficiency of crops and cropping systems to increase farmer profitability and agricultural sustainability. Jake relies on the basic principles of ecology, field and lab experimentation, statistical analysis, and simulation modeling to contribute information to scientists, farmers, and policymakers. Carmen Fernholz grew up on a small farm with his parents and 8 siblings just down the road from where he now owns and operates A-Frame Farms. A-Frame Farms is an organic operation that he and his wife Sally started in 1972 with 80 acres. Today, the Fernholzes raise certified organic small grains, corn, and soybeans on 360 acres. Over the years, Carmen has been recognized as a leader in the organic field and plays an important role in counseling farmers and others who are interested in this type of agriculture. Carmen has been partnering with CFANS faculty for decades and was the first Minnesota farmer to plant Kernza in 2011. As our experts present today, please enter your questions into either the chat box or the Q&A link. And welcome, Jake and Carmen.
Thanks so much for the introduction. I'm going to share my screen here real quick and we'll get started with the presentations. Okay. So I want to give a special thanks to Meredith, Annie, and Mary for putting this together and for the invitation to speak today. I'm super excited to talk with all of you about this new crop, Kernza. I also want to give a special thanks to Carmen. We are so privileged to have this pioneer in organic farming here with us today to talk about new sustainable crops and the future of sustainable farming. He's been a real inspiration for me, and while I develop my research program that is really integrating University of Minnesota research and farmer participation, something I look forward to doing for the next few decades of my career here. I want to start off with a 10,000 foot level of agriculture here on planet Earth. So for 20,000 years, we've been domesticating wild plants to turn them into crops so that the human population can grow and to improve the well-being of humans and communities around the planet. In the last century, we've seen some really major advancements, technological advancements that have increased the yield of agriculture globally. From research right here at the University of Minnesota with Norman Borlaug on new ways to breed plants, and also the mechanization of agriculture. We've really rapidly increased yields of crops and the footprint of agriculture on the planet. Take a look at that footprint. It's about 3.8 billion acres, or about 12% of all of planet Earth's surface is now farmed with crops. And if we zoom in a little bit, take a look at those fields, almost half of them are occupied by 3 crops. And these are extremely important staples for humanity. They make up for more than half of the caloric intake by humans. This is corn, wheat, and rice. All 3 are annual grasses. So we've been hugely successful increasing yields, and that was the primary goal during the 20th century. But as a result, we've displaced some of our natural landscapes that are really important for providing ecosystem services. Some of the ecosystem services listed here, like resources for pollinators, habitat for wildlife, quantity and quality of water regulation, so on and so forth. So as we've replaced these natural landscapes with annual row crops, especially low diversity annual row crops, we've actually displaced some of these ecosystem services. Locally, that has resulted in both detrimental impacts to human health and our economy. This map shows areas of nitrate leaching throughout Minnesota. The red dots are actually wells that have nitrate levels that exceed the safe drinking limit set by the EPA. So of course, this is a problem, a major issue for human health. Nitrate in our drinking water leads to blue baby syndrome, but it's also an economic issue. These small rural communities are having to pay thousands of dollars per household to mitigate this challenge. This is also a national issue. There are a lot of different environmental issues related to agriculture, including nutrient losses to like the Gulf of Mexico. This is just one example that I'm sure you've heard of before. And again, this has human health implications and economic implications. So one of the goals of the Forever Green Initiative and other research here at the University of Minnesota is to change our cropping system and to change our systems to develop agriculture that provides both high yields and ecosystem services. So balancing the economic outcomes as well as the environmental outcomes that also indirectly have financial and economic benefits. One way to do that is with perennial crops. Now we have lots of perennial crops. We have things like alfalfa, perennial forages. We have perennial fruit trees. But what we don't have until now is a perennial grain crop. And we are working with the Land Institute and many other institutions on developing the world's first perennial grain crop. The plant is called intermediate wheatgrass, and the grain harvested from this plant is called Kernza. I'm going to refer to the plant itself as Kernza as well, just because it's a lot easier to say than intermediate wheatgrass over and over again in a presentation. So Kernza was identified as a great candidate for a perennial grain crop because it has relatively large seeds for a perennial grass. It has this deep, dense root system that it's really well known for, which provides those ecosystem services that we're looking for. The filtration of nutrients from the water, the carbon sequestration. It's also tolerant to a wide range of growing conditions. So it can be planted and used across the US and beyond. I'm going to give you just a real quick overview of the life cycle of a Kernza production system. Unlike most of our annual crops, we plant this in the late summer, early fall, and then the plant just grows vegetatively from about September until the snow flies. So then it provides this green living cover throughout the winter, which helps protect soil from erosion. The Kernza plants begin growing immediately as soon as the ground's thawed, and just primarily vegetatively in the beginning, in the first couple of months. The plants then elongate and go through anthesis and flower, which is happening right now. And then the grain matures and is ready to harvest in early August. Grain's then harvested, and then all of this high quality, high value straw is also removed. And then the plant continues to grow from that point on until the snow flies again in sometimes October, providing again cover throughout the winter. And this cycle will continue with spring regrowth for many years. But in the context of grain production system, we're looking at about a 3-year system for profitability. I'm going to give you a real quick overview of some of the research at the University of Minnesota that's going on around Kernza. Of course, there's a lot of breeding and genetics work going on here. The University of Minnesota plant breeding team, led by Jim Anderson, has recently released the world's first Kernza variety. That's Minnesota Clearwater. So that came out of this program, and it's a very active program that will be releasing varieties for the future to come. We also have a team working on agronomics, and I do a lot of the work related to agronomics. I'll talk a bit more about that in just a bit. We also have a side team working on the environmental impacts, quantifying and measuring those ecosystem services that could come out of this system. That's all great. All of the research is great, but we need to make sure that this crop can get out onto the landscape. So we have a team focused on implementation, disseminating the research, the plant material to farmers and end users. We have a team working on the food science. How can Kernza be used in food ingredients? And then of course, commercialization. We need to figure out the supply chains and the marketing scheme to get Kernza onto the shelves of our supermarkets. So I just want to touch on a couple of these research activities here at the U. From the Kernza breeders, the #1 priority here for their objectives is to increase seed size and grain yield. And the team has been very successful in doing so. They've increased grain yields by about 5 to 10% per year since initiating this program. One of the reasons is because the team here has sequenced the genome of Kernza. So this means that we have a better idea of which genes relate to certain traits like big seeds or the quantity of seeds. And this allows the plant breeders to use their traditional plant breeding techniques when developing the new varieties. So there's no genetic modification going on in this program. We're just using the genome to speed up the traditional plant breeding process. I'll talk a little bit more about the agronomics team. So we're studying all kinds of agronomic activities from establishment all the way to the end storage and management of grain as it leaves the farm. Just want to highlight a few things. Of course, one of the major objectives is to increase grain yield. We're looking at how we can manage fertility, specifically nitrogen, to increase grain yields, looking at rates, timing of application, some of the very fundamental aspects of small grain farming, like row spacing. With Kernza, this is a brand new crop. We kind of have to start from scratch, and it functions very differently from a lot of our annual small grains. Harvest techniques, how do you harvest this? Swath it versus direct combining, what are the pros, what are the cons? Economics behind all of these, major part of the research program. Also, companion cropping for establishment. This is really important and a great potential to introduce diversity to the farm. We can also look to increase profitability in other ways, not just by increasing yields. One way is to reduce inputs. So how can we be more efficient with our inputs to increase profitability and hopefully result in the success, economic success of this new crop for farmers? Legume intercropping is one way to do that. Legumes intercropped into a Kernza system could reduce the nitrogen fertilizer inputs required by farmers, because those legumes can fix nitrogen from the atmosphere and make it available to the Kernza crop. Dual use is another way, looking at a Kernza system as a way to provide both forage and grain. So two different revenue streams from a single field. There's a lot of research going on around this. So here's a map of all the different trials, agronomic and environmental monitoring trials going on across Minnesota, different ROCs and on-farm research. You can see that we're covering a wide gradient of soil types and precipitation and temperature patterns. Just highlight a couple of the focuses on environmental impacts. I've already mentioned nitrate leaching. This is a major issue for Minnesota. And we have a lot of preliminary evidence that suggests that Kernza can indeed reduce the amount of nitrate that leaches to the groundwater. And this preliminary data has led to a number of large-scale projects now that are on the landscape, large-scale research and demonstration projects that show just how effective Kernza can be in reducing nitrate leaching. This figure shows the amount of nitrate in the water, in the soil water beneath the rooting zone. This red line is that EPA's safe drinking limit of 10 parts per million, or 10 milligrams per liter. And we're looking at these trends through time, through a single growing season. And the gray line is corn. And this is what we often see from many studies and measurements of nitrate loss beneath corn. This pattern is very similar. We see these losses early in the spring, and then the nitrate is used up by the corn as it grows throughout the heart of the summer. The blue line here is switchgrass, another perennial grass that's used for biomass. And then we have our Kernza, which is consistently below the safe drinking limit. And this data has been used, as I mentioned, to talk to different state agencies and show that perhaps this crop could be used in these wellhead protection areas to protect the state's drinking water from nitrate contamination. Carbon sequestration is another ecosystem service of interest here. We've been measuring the carbon balance and greenhouse gas emissions in Kernza and other perennial cropping systems. This is a photo of Galen Bergquist. He was a master's student in the program, just defended in 2019. He's measuring greenhouse gas emissions from a Kernza field here. We're also doing a lot of deep soil coring to look to see how that carbon is changing in the soil and to measure how much carbon is in those deep, dense root systems. And this figure shows the carbon balance. So anything less than 0 is actually a net uptake of carbon. Anything above 0 is an output of carbon. This is just a snapshot of 1 year of data. We have to look at these systems, look at multiple years of data to really quantify that footprint holistically. But here we are seeing that there is indeed a net sequestration of carbon from these perennials. Of course, we need to work with a lot of different stakeholder groups, farmers, end users, land managers, to get Kernza on the landscape to realize these environmental benefits. To do that, we're conducting some modeling exercises to figure out just where on the landscape we can plant Kernza to maximize both the economic output and the environmental outputs. We're developing tools for growers so that they can more easily adopt to this new system. And of course, working with Extension and other outreach organizations to spread the word about Kernza and how it can be used in various farming systems. I just want to highlight a couple of projects here. These two were funded by the state, the LCCMR, and they're really unique because they include those multi-stakeholder partnerships. As you can see listed, we have state agencies, we have municipalities, rural water providers, all working together to continue to do the research, to measure the nitrate leaching and the mitigation of nitrate leaching really to the groundwater, and then actually produce Kernza on the landscape from wellhead protection areas and get that Kernza into the marketplace. So you can see we are even partnering with breweries to brew beer with that Kernza that was harvested from wellhead protection areas. And an essential component of all of this is working with the farmers and these other stakeholders. So this is just a map with the names of some of the farmers and different stakeholders who are growing Kernza at almost a commercial scale, followed by the number of acres in these different regions. And this is even a bit outdated now. We're expanding acreage quite rapidly here in Minnesota with the release of the new cultivar. But just a kind of a quick overview of where Kernza is in Minnesota and who's participating. I want to acknowledge a large team of researchers and others, agencies, and other stakeholder groups who are participating in these projects. And then, of course, the funding. We've been very lucky to receive funding from both state and federal sources, as well as Clean Water Fund and the Forever Green Initiative, and also foundations, private foundations, the Land Institute, the Malone Family Foundation, and the General Mills Foundation. So without their generous contributions, none of this would be possible. I just want to throw this slide up here with my contact info. Feel free to reach out if you have any questions after presentation and after the discussion. We can follow up. And now I'm going to shift gears and introduce Carmen Fernholz, and I'm going to swap slides real quick. All right, now we're going to hear from Carmen about how Kernza can be incorporated into farmers' operations through the use of a co-op and strategies for marketing this new perennial grain crop.
Okay, thank you, Jake. I really appreciate that. And it's really a privilege for me to be engaged in this whole research. And just to give a little bit of background, it was in 2011 that Dr. Don Wise gave me enough Kernza seed to plant a couple of acres on my farm. And so I tried it. I planted these 2 acres and experimented with harvesting and things of that sort. And what was really exciting was to see that over time, when I planted the next crop, which was in 2018, that the seed size alone had nearly doubled. And it told me that the research was really moving forward, and it was moving forward in a great direction. So yeah, click the slide again, Jake. And so one of the questions though, and Jake somewhat alluded to it, was that we can develop a crop, but we also have to develop a market. And we have to keep those two things in balance. And so that really got some of us talking about how we can do this. And so it brings us to the idea of why a farmer cooperative. And the answer that I came up with in the next slide is that we need to meet the needs of the farmer producers taking on this investment. It's a total new investment, and it's a new risk in agriculture. It's a new crop, and there's a new concept in food production called perennialization, as the next click shows. And farmers, their only experience with perennial crops really is alfalfa. And so if we're looking at a really food crop on a perennialization basis, it's a new challenge. So moving on, what is the challenge? And for me as a farmer, having farmed for 40 some years, Kernza presents the challenge of growing, harvesting, and moving a new grain with food grade quality in an economically viable market in reliable, dependable amounts, as it states there. And so if I'm out here on my own with 30 to 40 acres of Kernza, how am I going to be able to get into the market? How am I going to know even where the markets are? How am I going to know the quality? And so that becomes the real challenge. And so what I've seen over time is that if we're going to move it forward, we have to move together as a group of co-ops, as the next slide talks about some of the challenges. And so what are these agronomic challenges? Or as a farmer, we see them as unknowns. And I picture a group of farmers sitting in a coffee shop talking about Kernza and what's going through their minds. And the first thing we find out is, should we grow it organically or non-organically? We're finding that we can do it both ways, but initially the greater interest seems to be it as being grown as a non-organic crop. So the next question that would come up would be rotation sequence. Where does it follow in a rotation? As Jake alluded to, in our part of the country, the optimum planting date is usually in that right before, right after Labor Day. Well, also in our part of the country, corn and soybeans are the major crops, and harvesting of corn and soybeans is too late to really take the risk out of planting the Kernza. And so many of us may have to introduce it after a different crop. In many instances, especially in organics, probably another small grain crop, wheat, oats, barley, or something of that sort. So that would be that. The next question would be seed sourcing. And up to this point, we've really worked together with the university and sourcing the seed, making sure it's a viable seed, and making sure that we've got adequate amounts, because it's not something you just go down to your local seed company or seed store and buy it. Okay, so the next question then becomes seeding equipment. Generally what I've found in the experiences that we've had so far, and we've planted 15 acres in 2018, and we've planted in 2019 another 20 acres, and we found that if we have a good grain drill with a grass seeder attachment, it works quite well. And this is this is a big asset for farmers because it means that they don't necessarily need to invest in new equipment. So that takes care of that question pretty much. The next one is seed bed preparation. So how do we go about planting the seed? How do we prepare the seed bed? And generally we are finding that it's pretty much like a lot of other small grains. A firm seed bed, but the one difference with the Kernza seed is that it's planted a lot more shallow, generally that ½ inch to a maximum maybe of an inch in depth, which is a little bit different than the wheat and oats and barley thing. So we're still learning those things, but a lot of that issue has been resolved. The next question is seeding rate, and here we're sort of we're not really fixed on any really solid rate yet, but I think we're zeroing in on it, and I would leave that to the researchers to really determine what the rate is, because our concern is a drop in yield after the second or third year, and is there a way that we can extend that yield longer by the seeding rate that we actually use. Row spacing is another one. I personally plant the rows at about 6 or 6.5 to 7 inch spacing. Some people are experimenting with wider spacing in order to keep the grain from becoming sod bound at an earlier date. But that's the question that we're still working on, but I think we're starting to get answers to it. The next question is optimum seeding time. I mentioned this briefly, and it looks like that days before or after September 1st seem to be the optimum time. In the 2 years now that I've seeded them in Clearwater, we've had excellent seed growth in the fall. Looks like good overwintering and coming to life early in the spring. And so it looks like we're really zeroing in on a good time for seeding. Fertility. A lot of questions here. In small grains, we know as farmers that if you fertilize too heavily with nitrogen, for example, you can have serious lodging, and then this is going to reduce yield, and it's going to cause issues with harvesting. And so where is the fertility level? And I'm finding that in our organic system, we do apply hog manure, but I'm also finding that good fertile soil seems to be a very important piece here. And I'm looking at the two fields that I have, and I can see a significant difference between the poorer soils on one end of the field and the more fertile soils on the other end of the field. And so it's really showing me that the right type of fertility depends a lot on the quality of the soil. And so what I'm really saying here is that if farmers are looking to grow this, that don't look at your poor soils, look at your soils where you would want to plant a good wheat or oats or other small grain crop as well, because it appears to do well in those soils. It also brings up the question about weed management, and that's tied to row spacing, seeding rate, and things of that sort. And right now, I don't believe there are any herbicides approved for Kernza, and so weed management is a challenge. But in looking at my second year Kernza in an organic system, it looks like, except for Canada thistle, we've really been able to do an excellent job of weed management. You can look over the field and absolutely not see a single weed sticking up at this stage in the game. This may change as it gets closer to harvest, but by then we've achieved our yield and can move forward. Another question is, what is the best time for harvest? And we know that the crop seed head ripens from the top down. And by the time the bottom of the seed head is ripe, the top could be shattering. And so trying to determine that time and the moisture are challenges we're still working at. And I think we learned a lot last year, and we learned a lot not only how fast the grain can dry, but what are some indications when it is dry. And so the next question then becomes harvesting equipment. And here I'm really grateful because we don't need to invest in any new equipment. We can use our current harvesting equipment, whether it's a windrower or whether it's a straight cut stripper head or draper head. And but we are finding out that if we can use a straight cut versus windrow, that we do have better opportunity of less seed shatter. And even on the straight cut, if we can use a stripper head versus a draper head, that we can get even less crop residue and what we call clean out and much cleaner harvested grain. So these are things obviously that we're still learning. And then the next question becomes post-harvest storage. How do we store it? Putting it in a bin with aeration seems to be the best. And this is critical as well, because we know at this stage of development that grain isn't necessarily going to move swiftly into the markets, because the markets are still being developed and a lot of large demands aren't necessarily there yet. So we really want to be on top of how good we can store it and how long we can store it. And then finally, transportation. How do we get it to market? Currently, some of the end users have limited facilities in which to move that grain. And so we're currently using totes, but I think in the future, we should be able to change that problem quite quickly. So that takes us to the next level then. What are the financial and marketing risks? And I'm going to go through these fairly quickly. So we got to know that we do have a reliable price, so that when we are trying to determine what it's worth, we can figure this out. And next, we have to know what uniform food grade quality, being that the grain is harvested in a large geographic area, how will this impact food grade quality? And if we want to get a large enough amount of a similar quality, it will be a challenge. Furthermore, a decreased yield over time. We planted and we know that year 1, year 2, we have good yield. It starts lowering. How do we deal with this? We're working on it, but it is a financial concern. And next, grazing and forage opportunities. There's a lot of work that we can still be doing here, but it may be a very positive piece to Kernza, because it will give us an opportunity to multitask, if you would, on the income possibilities for Kernza. And we're definitely going to be working on that on our farm here in the future. An orderly and timely shipment of grain, as I alluded to earlier. When can the grain move into the market? And as a result, when can the farmer then be paid for the grain? So that takes us to the next step, then market logistics, the transportation, the dispersed growers and processors. We don't have the good infrastructure right now, but we are working on that. And we're working on getting the growers to communicate with each other so that we can start accumulating the grain. There are limited processing facilities, and the processor capacities are certainly limits to all of this. And then finally, long-term return on investment. Jake did an excellent job in talking about the ecosystem services that this grain provides. But I want to keep emphasizing, as we develop this co-op, that the grower does in fact receive compensation for doing these ecosystem services socially, environmentally, and economically. And looking at all of these points, these have made me conclude that we need to have a farmer co-op. And so that takes us to the next question then, crop and market development. Moving on, Jake, some of the things that we need to look at here, and I'll sort of try to wrap this up. If we develop this co-op, what I see with the co-op is that it, through much of the work that I'm currently doing, can inform and advise the industry and the research through feedback from the growers. We can find out, as I did last year, for example, the different ways that we can harvest the grain and different ways that we can store it. And so the research, the academia, collaborators, they can take this feedback from the growers and then start asking those questions when they're doing their research plots. And at the same time, talking about and really emphasizing and raising the awareness level of the paradigm shift to monetizing the ecosystem services. In other words, pay the people who are really making these ecosystem services something of a reality. And then moving forward, I just wanted to show this picture because Don Wise and I have had a relationship over the years, and he came out to the farm last year, and we, in a matter of hours, we determined that that grain was ready to harvest. I won't go into the story about the microwave, but you can talk to me about it sometime. But anyway, to me, it was the perfect example of the sharing of information between the farmer and the researcher. And this has been such a tremendously beneficial thing to me as a farmer. And I see this moving forward on into the future with the university. Next question then is market development. The crop and market development by the research and development collaborators will then, with the sharing of information, continue to expand with the new and current funding models. And we got the current grants, but by continuing the feedback from the growers through the co-op and the information that the co-op gives them, they can continue to expand their research and continue to expand the financing for this. And so that takes us to the next step. And I just, what I think it really summarizes it here, the Kernza co-op in concert with the collaborating entities becomes the grower's voice for legitimizing the public and private funding needed. So the voice of the farmers feeding the university and other researchers about the benefits and the needs of Kernza can help this continue to develop the perennial agriculture that I think the Forever Green Initiative really exemplifies. And obviously our poster boy right now is Kernza, but I think the opportunities for other perennials is out there for sure. And if we have a model of a farmer co-op cooperating with the university, I think we can move this forward. And so finally, that brings us to the final comment here, and that is incorporating Kernza into agriculture will be successful to the degree that farmers define, cultivate, and market Kernza's social, environmental, and economic ecosystem services. The farmers are going to have to define that in practice, but in practice, in defining it, show it to the researchers and show it to the public. And because, and if we think in those terms, then in terms of marketing, Kernza must be monetized to reflect these services. And it must remain an integral part of the Kernza market price discovery. So to me, the most important piece of Kernza is, obviously it's a new crop, but to me, the most important piece of Kernza is its economic or ecosystem services. But in order to perpetuate those services, they need to be monetized at a profitable level. And I think that's where the co-op comes in, because the co-op, through the structure that we're talking about currently with the growers in Minnesota, we will be able to fulfill a lot of the needs of making the ecosystem services available. And with that, I guess I would wrap it up, Jake and everybody.
Thank you so much, Jake and Carmen, for the great presentation, and we'll go to the Q&A now. So I'll just announce a few questions. And Jake, do you mind pulling up your presentation, screen sharing your presentation again, so that we can flip to any slides if you'd like to use that as you answer any questions here?
Sure thing.
Thank you. So the first question, and Carmen or Jake, feel free to answer, is in our Q&A, we have a question from Roger. Where did Kernza come from? Does it have a native habitat?
Sounds like your question, Jake.
Yeah, Kernza, or intermediate wheatgrass, comes from the Afghanistan region, and it was introduced to the U.S. In the early 1900s as a pasture and forage grass. So it's been here and considered somewhat naturalized here in the United States, North America. And you can actually find a number of different cultivars that have been bred by the USDA, forage type cultivars for different regions of the US. So it's pretty much made its home here. Kernza is really just an advanced population of intermediate wheatgrass with bigger seeds and more of them for functioning as a grain crop.
Thank you. And Jake, just so you know, your video is turned off right now if you want to turn that on so we can see you answer.
Sure.
The next question is, are there pests that attack Kernza?
Right now, so Jim Anderson would respond and say that Kernza, or intermediate wheatgrass, is it is not affected by all of our major wheat diseases. In fact, researchers in the past have used genes from intermediate wheatgrass to introduce resistance to wheat and some of our small grains. So it's really, a lot of the fungal diseases are not an issue right now for Kernza. That will likely change as it is expanded across the landscape, but right now we're okay with that. Ergot is an issue at times, which is an issue for all small grains. It really depends on the year. But that's probably our major concern right now would be ergot.
And we did see a little bit of Don in some of the crops last year, didn't we, Jake?
Yep, and that's another issue, and we're really trying to figure out when and how that's introduced to the grain. And we've also learned that once we dehull it and get the seeds out of the hulls, that issue can be reduced dramatically. So it seems like a lot of the mycotoxins that might grow on it, whether it's in the windrow or maybe just when it's still standing and before direct combining, seems like a lot of those mycotoxins are on the hulls and on the seed head, not really the seeds themselves. So we're learning a lot about that as well.
Good.
Thank you. We've had a couple questions here that I'll combine and ask, what is the gluten content of Kernza? And then how do people with gluten sensitivity respond to Kernza?
Great question. There's a lot less gluten in Kernza than wheat, but there is still gluten, and it still has the allergens or the proteins that make people who are sensitive to gluten react. So it's at much reduced levels, but they're still there. So one idea for the future is to breed a line that has no gluten, potentially a gluten-free Kernza type. But a lot of other stakeholders are interested in increasing that gluten level because that's what helps our bread rise. So perhaps in the future we'll have two different varieties or cultivars of Kernza, one that's gluten-free and one that has higher levels of gluten, so it can be more easily used in baking products.
Great, thank you. How does Kernza compare to winter wheat, and could it be used for bread baking?
Yep, it can definitely be used for bread baking. In terms of winter wheat, it has higher protein content. It has higher protein content than a lot of our annual small grains. But then again, the lower gluten content. So kind of some trade-offs here. When used in baking bread, a lot of bakeries have been mixing it to some degree. 50% wheat, 50% Kernza is kind of at the max. Those who have tried long fermented sourdoughs have been able to increase that Kernza ratio a little bit. But there's a lot of people who are using 50%, 25% Kernza flour in different baking products that require a rise. Now, for things like pasta noodles, for tortillas, anything that doesn't require a rise, Kernza can easily substitute all of the wheat in those products. And it results in a product with a different nutritional profile, but a good nutritional profile, so higher protein, and there's some other antioxidant levels that have been increased as a result of increasing the Kernza fraction in the product.
Thank you. Here we have a kind of location question. Could Kernza be grown across the entire US, or is it localized to the Midwest? And to combine that with another question, someone asked, how many acres of Kernza are growing in Minnesota this year?
Great questions. So we have collaborators, partners working on research in Utah, where they get, I think, like 18 inches of rain a year. And some of those really arid dryland partners are looking at irrigating Kernza. Some are looking at growing it in dryland conditions and seeing just how dryland can we grow Kernza. And it was bred in Kansas, which is very, very hot and a little bit drier than here. So we know it performs well there. On the other end of the spectrum, we have partners at Cornell who have been doing a lot of testing with Kernza, where they get significantly more rainfall and precipitation than us here. The plant does require vernalization, so it needs a prolonged, extended period of cold temperatures to produce flowers and then seed. So we're trying right now to figure out what is that southern limit of production. We have some collaborators, actually, University of Minnesota CFANS alum, who are now faculty at Texas A&M, and they've planted some Kernza to see if it indeed can get cold enough to produce seed down there. So we're testing it all over the US, actually all over the world. We have collaborators in Australia, Sweden, South America, and right now we're just trying to figure out that range of profitable, economically viable production.
And in Minnesota, I think we're approaching 1,000 acres, I believe. And that's sort of part of the reason why we're looking at this co-op in Minnesota, so we can accumulate the acres and consequently accumulate the bushels, and at the same time share all of the agronomic challenges. But yeah, I think I'm right on that, Jake. Am I? We're approaching 1,000 acres?
Your guess is probably better than mine. I've been having a hard time keeping track. We've been recruiting a lot of growers this summer with the new variety release. So I think that's about right, about 1,000.
Right.
Thank you. I think we have time for one more question here, so I'll pull this from the Q&A. Would you talk more about any suggestions for how to go about using your farmer co-op model to monetize the ecosystem services that Kernza provides?
Repeat the question quickly again.
We had a question from Barry. He asked, would you talk more about any suggestions for how to go about using your farmer co-op model to monetize the ecosystem services that Kernza provides?
Excellent question. I appreciate you asking it. Probably what we're talking about is when we as a co-op would approach the markets, we would have to clarify and define for them the ecosystem services that we're actually practicing on our farms, and determine the value. Now, how we go about determining that value, that's where we're probably going to have to incorporate some of the ag econ people at the university and see what these values do play in the overall environment that we work on. But most importantly, and I think the question that we really want to talk about when we are marketing this is, how do we also impact the social part of the ecosystem services? In other words, how do we set up a value on that Kernza that can help new farmers come into farming and grow the Kernza, and thus be people who are working with the environment as well. So it's not do this, do that, and do the next thing. It's going to take negotiation, it's going to take discussion, and it's going to take time to really put a value on these services. And I really say that because I think we really haven't valued the service. Too often we've gone for yield and somewhat neglected the other areas. And so that will be a piece of the co-op that we're definitely going to emphasize, that we want to put a value on those services. And so it's going to be us defining that in the long run.
Thank you so much for answering our attendees' questions, and I will pass it back over to Annie, and I will stop sharing the screen here.
Thank you so much, everybody, for all those great questions this afternoon. And thank you to Carmen and Jake for sharing all that great information. It's just so interesting to learn more about all the considerations that go into successfully bringing a brand new crop to market. I hope you guys all really enjoyed the session and that you have a better understanding about the important role that Kernza can play in the future of agriculture and ecosystem services. So I'll just turn it back over to Mary to wrap up the event.
Thank you, Annie. In case your interest has been piqued as a result of this presentation, we wanted to share a few locations of where you can find Kernza products in your community in the form of beer, bread, and other products. This next slide includes a Kernza beer bread recipe and information on how to order flour from Perennial Pantry. We'll be sure to include these details in a follow-up message to you all. We're also really pleased to share with you that a Forever Green partner, Columbia County Bread and Granola, has shared a code to receive a 20% discount on Kernza crackers. These crackers were made from UMN Minnesota Clearwater Kernza grown on Carmen's farm. The discount code will be sent along with the program survey that I hope you will all complete immediately following the session. As we close, I want to acknowledge Annie for your vision, commitment, and leadership that was the foundation for today's program. Thank you to Jake and Carmen for this informative presentation demonstrating the important relationships between U of M researchers and farmers. And Meredith Dwyer for your support and expertise in facilitating the program today. Thank you all again for joining us in this virtual program. We look forward to seeing you at a future Classes Without Quizzes. Have a great day and enjoy the July 4th holiday.